Compared to element 2, element 1's atomic radius is definitely smaller, probably bigger, or definitely bigger. Well, if we look at shielding, this factor increases atomic radius. So if shielding is bigger for 1, then that's a tick in the column that 1 has a larger atomic radius than 2. What about for effective nuclear charge? Effective nuclear charge, on the other hand, decreases atomic radius. So because element 1 is smaller in effective nuclear charge, that's also a tick in the column that 1 is larger than 2. So both pieces of evidence tell us that element 1 should have a larger atomic radius than element 2. Therefore, element 1 is definitely bigger than element 2. Here's a new set of elements. Compared to element 1, element 2's atomic radius is definitely smaller, probably bigger, or definitely bigger. For shielding, again, element 1 has greater shielding than element 2, so because shielding increases atomic radius, that's a tick in the column. That's evidence that 1 has a larger atomic radius than element 2. But for E and C, evidence suggests that element 2 should have a larger atomic radius because it has less E and C. Both pieces of evidence support different situations, with shielding pointing to 1 being bigger, but effective nuclear charge pointing to 2 being bigger. So how are we going to reconcile this contradiction? Well, it just so happens that when it comes to impacting certain factors of elements, such as atomic size, shielding is far more impactful than E and C. So it's more likely that 2 is smaller than 1 on the basis of shielding alone, still acknowledging the fact that E and C difference could be really big and shielding really small, so 2 is probably smaller, but not definitely smaller than element 1.